All right, today we're going to do lesson 3.2. So one of the things we want to do is we're going to solve systems of equations on pairs of linear equations in two variables, all right? So what we did was this. There's two methods, substitution method and elimination method, all right? What I tried to teach is that if one variable is already solved for, I would use substitution. And the second thing with elimination, if the variables are lined up, I'm going to use elimination, okay? So let's take a look at what our notes say. So first of all, example 1. Here we go. So what I see in example 1 is this. I've got y equals. So I'm going to definitely use substitution. When I do these, I like to write them side by side. So let's rewrite them. Y equals x plus 2. And let's write x plus y equals 8. Okay, we're going to use substitution because I know y is equal to x plus 2. So if I have one of the two variables already solved for, then it makes an easy substitution. So to substitute, I'm going to take my x plus 2, that's what y is equal to in my first equation, and I'm going to rewrite it over here. So instead of writing y, I substitute in its place x plus 2. Okay? So here instead of writing y, I'm going to write what y is equal to, which is the x plus 2. So let me rewrite this equation. I'm going to write this x here plus, but not y anymore, but what y is equal to. X plus 2 equals 8. Okay? And now I can solve for x pretty easily. X plus x is a 2x plus 2 equals 8. Minus 2, minus 2, right? We're just going to solve for x. 2x equals 6. Divide by 2, x is 3. Now we're still looking, though, for a point, okay? So the answer is a point. Here's what I know about my answer so far. It is 3 something, right? So if x equals 3, I've got half the answer because it's a point. I got 3 something. To get the other value, I'm going to substitute this answer into the first equation. Well, I already know what x is. So if I put 3 here, I'm just going to get 3 plus 2, which is 5. So I'm going to substitute that into my first equation because I know x is 3, right? So I go y is equal to 3 plus 2, or basically y is equal to 5, right? What did we do? Well, we didn't have to graph this. We could have graphed it on graph paper. We could have started at 2, went up 1 over 1, up 1 over 1. We could solve for y. We could have graphed it, and where the two lines would have intersected right here. But the cool part is we did this without any graphing at all. Without even looking at the graph, we know that the two lines will intersect at 3, 5, okay? Are you ready for example 2?
Yeah. Yes.
Now this one says solve by substitution. So the only problem with this one is that we don't have a variable solve for it. So let's rewrite them both side by side. 2x plus y equals 6 and y minus 8x equals 1, okay? So when I do substitution, I've got to have one of the variables by itself. It's either got to say y equals or x equals. So in both cases, here I could solve for y and bring over the 2x, right? Or in this case, I could bring over the 8x. It does not matter. I think for me, it's easier to bring over the 8x because then I'm dealing with positive numbers. So if I add 8x, I'll have y is equal to 1 plus 8x, right? So to do the substitution method, you've got to have one of the variables already solved for, okay? So now, I'm going to take 1 plus 8x, and I'm going to substitute it in for y. Instead of writing y, let's write 1 plus 8x. So I'm going to substitute. This is what y is equal to. 1 plus 8x, I'm going to put it right in there. So I'm going to go 2x plus y, but I'm not going to write y. I'm going to write what y is equal to, plus a 1 plus 8x equals 6, okay? So I just put in my 1 plus 8x where y was in the first equation, just substituted. Now my entire equation is in terms of x's. 2x plus 8x is a 10x plus 1 equals 6, right? So I'm just going to simplify 10x, solve minus 1, 10x equals 5. Divide by 10, and the answer is 1/2. Okay, 5 divided by 10 is 1/2. Okay, now that's half my answer. So I do know my answer is this. My answer will be a 1/2 something. But to get the something, let's just take the 1/2 and plug it in right here. Okay. So instead of 1 plus 8x, we'll go y is equal to 1 plus 8 times 1/2. Because I'm just going to substitute the answer of x, which is 1/2, into the equation 4x. All right, 1 plus half of 8 is 4. 1 plus 4 is 5. So that's the other part of my answer. So I'm going to have an answer of 1/2, 5. So we didn't have to graph these. If we did graph these two lines and found out where they intersect, they'd intersect at the point 1/2, 5. It's really not that hard. You guys did this in algebra, okay? Now, example 3, elimination. Here's when I like elimination. Check it out. X's are lined up, right? Y's are lined up. Equal signs. I like the elimination. In fact, this is a really easy one to do because if we're going to eliminate, if I subtract straight down, check it out. 3y minus 3y. What's going to happen right here?
Cancel.
This is a really easy problem because I don't have to multiply anything. I can just add them. You guys agree? These are just going to cancel right off the bat. So if I add them straight down, I'm going to get a 6x. And the reason I'm going to add them because they cancel. You guys said it right. Those cancel, right? Equals a, if I add them, I get a 30, right? Now solve for x is easy, right? Y's are gone. X is by itself. Divide by 6. X is equal to 5. Okay. Now again, we've talked about the fact that our answer is a point. Our answer is 5 something. Now if x is 5, we need to find y. We've got to get the other half. Probably the easiest way to do it is to substitute in the 5. I can either substitute into the first equation or the second. It does not matter. I can either substitute into the, I'm going to put 5 either there or put the 5 there. It does not matter. Dylan, do you like the first or second equation? First equation, great. I would agree because it's all positives, right? It does not matter which one you pick. So Dylan picked the 2x plus 3y equals 34. I think that was a good choice because they're all positive. So let's put the 5 right there. Right? So 2 times 5 plus 3y equals 34, right? And let's find out what y is so we get the other half of my answer. 10 plus 3y equals 34, right? Minus 10, minus 10. I'll have 3y equals 24, right? Divide by 2, 3 goes into 24 how many times? 8 times. So I have both parts of my answer. The reason I need both parts, it's a point. It's two lines that intersect in a point. That's why I need both the 5 for the x and the 8 for the y. Okay? How am I doing? Okay? Okay, ready to turn the page? Alright. Now, example 4. It says solve by elimination. Now here's the problem. I'm going to flip it back for a second. Just watch. Don't write anything down. Just watch. Oh, I like this problem. This problem was so slick because 3y negative 3y, right? Boom. They just cancel. They're opposites, right? You guys agree? This was an easy problem. But on example 4, nothing's going to cancel. But if I multiply, and on the example here, remember I multiplied by 2 and I made them to be opposites, right? But on this one, I'm going to have to multiply both. I'm going to have to multiply both. So one thing I'll tell kids, think of a common denominator, okay? So do you want to cancel the x's or the y's? Does not matter. X's, cancel the x's or the y's. Does not matter. Which one do you want to cancel? Okay, all he says x's. Okay, here's how I'm going to do it. Here's how I'm going to do it. If I can make this a 6x and this a negative 6. Okay, listening? If I can make this a 6x and this is a negative 6x. Dylan, you want to put your phone on my desk, please? If I can make this a 6x and this a negative 6x, they'll cancel, right? So check it out. If I multiply this by a 6 and this by a negative, oops, I don't want to do 6. How about 3 and 2? I got distracted. Thanks, Dylan. How about this, a 3 and a negative 2? If I multiply this by a 3, what's that make that? If I multiply this by a 3, if I multiply this by a negative 2, what's that make? Would they be the opposites of each other? So let's do that. Let's go ahead and rewrite both equations. So now I'm going to have a 6x. And you got to multiply everything. Multiply everything. Everything. Okay? Everything. So I get a 6x plus a 12y equals a negative 30. Okay? Multiply everything. I'm going to get a negative 6x negative 6y equals 6. Okay? Now, do I have opposites? Do I have opposites? Do I have a pair of opposites up there? You guys see a pair of opposites up there?
No.
You guys see that?
Oh. Yeah.
Hey, I like that because if I add these now, what's going to happen? Cancel. So if I cancel out the x's, I'll have a 6y equals a negative 24, and I could solve for y, couldn't I? Okay, so divide by 6, y equals negative 4. So now remember, my answer is a point, and my point is something negative 4, okay? Put it in the y spot, something negative 4. How do I find the x value? Plug it in, right? So, Abby, do you want to plug it in the first or second equation? Does not matter to me. First or second? Okay, she wants to put it in the second equation, so she's going to put 3x plus 3y into negative 3. Let's put a negative 4 in for y, right? In for y. So I'll put a negative 4 right there. 3x plus 3 times negative 4 equals negative 3, right? I'm recording. 3x minus 12 equals negative 3, right? Right? Add plus 12, 3x equals 9. Divide by 3, x is 3, okay? So what we got, again, is we got a point. If I were to graph these two lines, it's kind of a pain to graph these, you guys agree? That'd be a pain. I'd wind up as an intersection point right there, okay? Do you need Abby real quick?
Well, yeah, she doesn't have to go.
Okay, I got 3 more examples. Okay, so let's get these examples done. Okay, example 5. All right. All right. What do you think? Look at example 5. What do you think? Anybody have any ideas? I want to multiply to make something the opposite. I want to multiply to make something the opposite. Any ideas? What about the second equation? What do you want to multiply this second equation by? What if I made that a negative 8? Could I make that a negative 8? How would that help me if I make that a negative 8? Hello, wake up. If this were a negative 8y, what would that do for me?
You can cancel it.
Good. So why don't we make it a negative 8? Because we want to cancel. So how do we make it a negative 8? Let's multiply by negative 8. So let's see what happens. So my first equation, 56x plus 8y equals negative 32, right? My second equation, what's 7 times 8, you guys?
Negative 56.
Negative 56x minus 8y equals 8. And if I add them up, what happens?
The 56 goes over.
That's gone.
And the y.
Ooh, something weird's going on. I got 0 equals what?
Negative 40. Or, no.
Does 0 equal negative 24? X is gone, y is gone. So it's either going to be parallel lines or the same line, right? Which one is it? Parallel, because it was the same line, everything would have canceled. Does that make sense? So it's got to be parallel lines. So the answer to this one is the empty set. That's the answer. Okay. All right, example 6. We're almost done. All right, take a look at example 6. All right. Okay, everybody awake and paying attention? If this were a negative 3y, if that was a negative 3y, would that help me out?
Yes.
Because then those would cancel, right? So to make it a negative 3, I'm going to multiply this by a negative 3 and see what happens, okay? So my first equation was a 6x plus a 3y equals negative 12. Second equation, ready? Negative 6x minus 3y equals 12. Okay, what's going to happen here? What's going to happen here?
They all cancel.
Everything cancels. So what does that tell you?
Same line.
It's got to be the same line, right? It's It's got the same line. So the answer, if they're the same line, they intersect everywhere, right? Because they touch each other everywhere. So that's going to be all real numbers. Good. All right, last problem. You ready? Example 7. Story problem. All right, a zookeeper needs to mix feed for the prairie dogs so the feed has the right amount of protein. Feed A, let's check it out. So if we got feed A is 12% protein and feed B has 5% protein, okay? So we're going to have an equation. I'm going to have a 12% protein, let's call it X, plus a 5% Y, okay, equals, let's see, how much we're going to have? 8%, right? 8% of what? 8% of 100 pounds, because that's how much dog food I'm going to use. Right? So I'm going to add so much of this. So X and Y is how much of each. So much of this plus so much of this should give me an 8% mix of my 100-pound dog food, okay? So let's change that to decimals. 0.12X plus 0.05Y equals 8. Because I'm going to go 0.08 times 100. That's what that says is 8. Okay, now what about my second equation? I have to have two equations. You have two variables, so you have to have two equations. Here's equation 1. Well, equation 2 is the amount of dog food. I'm going to throw in X amount of A plus Y amount of B. And how much do I have? I got 100 pounds. Okay. There's my two equations, okay? Could I solve those equations? Okay, I'm running out of room. Forgive me. Could I solve those equations? What would I do? We're almost done. Plus Y equals 100. All right, let's think this through. If this right here, see where I'm pointing? If this were a negative 0.5, if this were a negative 0.5, would they cancel? So let's make it that. Let's make it as, okay, so if I multiply this whole equation by a negative 0.5, I'd make them the opposite and they'd cancel, okay? So let's check it out. 0.12x plus 0.05y equals 8. That's my first equation. Second equation is going to be a negative, oh, I got the decimal in the wrong place. Sorry. Negative 0.05x minus a 0.08, oops, 0.5y, I am making mistakes, equals 5, all right? So I multiplied through, and the reason I did that is because when I add these, those are gone, right? So we're going to have a 0.07x equals 13. Now, gosh, that just seems like so much work, but it's not that bad because we use calculus, right? So if I go ahead and divide 13 by 0.07, I get an answer of 185. And I must have made a mistake somewhere. All right, I'm going to come back to this problem because I must have made a mistake somewhere because that's too much dog food because I only got 100 pounds. Okay, we'll come back to this. So I will stop the recording now before I make any more mistakes, and we'll fix that one, okay? All right. What in the world did I...